Hey everyone, and thank you for joining me. Today, we're going to be talking about two useful formulas with respect to factoring quadratics, which is the quadratic formula and the discriminants. So, let's start with the discriminant. The discriminant tells us how many zeros or x-intercepts or factors our function has, and it's equal to b squared minus 4ac. So, if d is greater than 0, then what that means is that I have two x-intercepts. If d is equal to 0, then I have 1, and if d is less than 0, then I have 0. You can see that d is also the part of the square root here, right? It's written under there. So, moving on to the quadratic formula, we have x is equal to negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. And this is very useful when factoring is difficult, right? When it's going to take you more than a minute or two to factor your expression. So, an example would be what we have written down here. 0 is equal to 3x squared plus 5x minus 17. This is where the method that I taught you before doesn't really work as well, right? So let's get into solving this example. Okay, so we're going to start with part A, which is going to be solving for how many roots the function has, right? So to solve the number of roots, we're going to use the discriminant, which is b squared minus 4ac. Okay, so a here is going to be equal to 3, b is equal to 5, and c is equal to negative 17. So to start with part A, d is going to equal b squared minus 4ac, which is going to give me 5 squared minus 4 times 3 times negative 17. Well, 5 squared is going to be 25, and because we are subtracting a negative, right, once this is all multiplied, we're going to be adding 204, which is going to give me d is equal to 229. Now, to move on to part B, solving the quadratic formula, we know that x is equal to negative b plus or minus the square root of b squared minus 4ac divided by 2a, or negative b plus or minus the square root of d divided by 2a. Okay? So this is going to give me x is equal to negative 5 plus or minus the square root of 229 divided by 2 times 3, or x is going to be equal to negative 5 plus or minus 15.133 divided by 6. Okay, so notice how from here there's this plus and minus. So what we're going to do is split it into two cases. So the first case, I'm going to say that that's x1, which is negative 5 plus 15.133 divided by 6, which is going to give me an answer of 1.69. And I'm going to say that there's an x2, which is negative 5 minus 15.133 divided by 6. Now that's going to give me an answer of negative 3.36. So if I say that x1 is r, which is 1.69, and x2 is s, which is negative 3.36, I get back that my x-intercepts, or the roots of my quadratic, should be located at 1.69 and negative 3.66. Alright, so I'd like to continue with this example here, where we have 5x squared plus 25x minus 30. Now, this was recently an example that we did both factoring and expansion for, so I just want to prove in this example that doing it the quadratic formula way gets me the same result as doing it the factoring way. So let's start by solving for the number of roots. So I'm going to have a is equal to 5, b is equal to 25, and c is negative 30. So to solve for the number of roots, that's going to be my discriminant, where I'm going to get d is equal to b squared minus 4ac. Well, here it's going to give me 25 squared minus 4 times 5 times negative 30. Well, that's going to tell me that it's 625 plus 600 for a final answer of 1225, which is larger than 0. So this tells us that using our quadratic formula, we're going to get two different results. Okay, so now we want to actually find what those roots are. So we have x is equal to negative b plus or minus the square root of the discriminant divided by 2a. Well, here, that's going to give me negative 25 plus or minus the square root of 1225 divided by 2a, which is 2 times 5. Or what this is going to give me is negative 25 plus or minus 35 divided by 10. Okay, so from here, I'm going to split into my two cases. So I'll draw one of them up here. x1 is going to be negative 25 minus 35 divided by 10, or negative 60 over 10, or negative 6. Now we're going to get for x2. So x2 is equal to negative 25 plus 35 divided by 10, or 10 over 10, or 1. So using the quadratic formula, we actually get the exact same results as we got just using factoring. Okay, so I'd like to go over the following example. So starting from the 3x squared plus 4x plus 5, we have that a is equal to 3, b is equal to 4, and c is equal to 5. So no surprises where we're starting. We're going to solve for the number of roots first. So d is equal to b squared minus 4ac. Well, here, that's going to give me 4 squared minus 4 times 3 times 5, which is going to be equal to 16 minus, and there 4 times 3 is 12, which is going to give me 60, or negative 44, which is less than 0. So you might remember that this means that it has no roots. But what does this actually mean? Well, if we plug it into our quadratic formula, you might remember that we have x is equal to negative b plus or minus the square root of d divided by 2a. And we go negative 4 plus or minus the square root of negative 44 divided by 2 times 3. Well, here's the thing. You try to compute the square root of that negative number, and your calculator is going to get an error. So what this means, and this is entirely possible in math, is that your quadratic equation is just above or below the x-axis for all x values. So it basically never reaches y equals 0. Okay, and now we're going to go over this example here. We have 4x squared plus 4x plus 1. So we're going to write out what is a, what is b, and what is c. Well, here, a is going to be 4, b is going to be 4, and c is going to be 1. So, plugging everything into the discriminant equation right here, you find that d is equal to 4 squared minus 4 times 1, or 16 minus 16, or 0. So that means that there is exactly one root. Okay? So, proceeding to the solution for the roots themselves, we have x is equal to negative 4 plus or minus the square root of 0 divided by 2 times 4. Well, the square root of 0 is 0, so we're going that it's equal to negative 4 plus or minus 0 divided by 8, or just negative 4 divided by 8. Now that's equal to negative 1/2, or 0.5 if you prefer it in decimal form. So this 1, 0 right here is actually the vertex. It's the x value of the vertex. And we'll come back to what that means later on. But for now, just know that if the discriminant is equal to 0, that tells us that there is only one root of the function. Okay, so I'll give you the following example to work on by yourself. Here, we're just going to solve for the two roots and what their values are. So you can go ahead and skip the discriminant calculation. I've already done it and I know that it works out. Okay, so pause the video and come back here when you're ready. All right, so to start on this problem right here, we're going to have A equals 3, B equals 12, and C is equal to negative 36. Now, the way that I did it before was calculating the discriminants and then plugging it into the equation. So doing it like this. That's good if you find you get overwhelmed with big equations, right? But plugging it in as b squared minus 4ac works as well. I'm going to show you that way just that you're comfortable using both of them. So we're going to have x is equal to negative 12 plus or minus the square root of, that's 12 squared, minus 4 times 3 times negative 36, all divided by 2 times 3. Okay, so let's take this one step at a time. X is going to be negative 12 plus or minus the square root of 144 minus 12 times negative 36 divided by 6. Now, that's going to give me x is equal to negative 12 plus or minus the square root of 144 plus 432 divided by 6, or x is equal to negative 12 plus or minus the square root of 576 divided by 6. Now, that's going to give me x is equal to negative 12 plus or minus, and the square root of 576 is 24 divided by 6. Okay, so from here, we're going to split into our two different x cases. So we have x1 is negative 12 minus 24 divided by 6, which here it's going to give me negative 36 divided by 6, or negative 6. And I'm going to have x2 is negative 12 plus 24 divided by 6, which is going to give me x2 as 12 over 6, or 2. So therefore, the roots of the function are going to be negative 6 and 2.